Hello everybody and welcome to my 38th video. This is a practical demonstration on the Quaternary JK and T-type flip-flops. Now we're going to start with the T-type flip-flop, and here I've got an oscilloscope. This is the clock on the bottom waveform, and this is the output of the T flip-flop on the top waveform. I've got the input set to a logic 1, the T input is set to a logic 1, and you can see that the output cycles up between 0, 1, 2, 3 and back to 0. It just cycles 0, 1, 2, 3, 0, 1, 2, 3. Now 0 is 0 volts, quaternary logic 1 is 3.6 volts, quaternary logic 2 is 3.3 volts, and quaternary logic 3 is 4 volts. 5 volts, sorry. So that is the T flip-flop counting up with the input, T input at logic 1. And I can demonstrate this clocking. It clocks on the negative edge of the flip-flop. See the output clocks when the clock goes negative. It goes to a 3, back to a 0. Now the flip-flop is clocked on a negative going edge from a quaternary logic 1 to quaternary logic 0. I've got a TTL 5 volt TTL oscillator here providing the clock. Right, so if we switch the output to a 3, T input to a quaternary logic 3, you can see it counts down from 3 to 2 to 1 to 0 and then repeats. And you can see that in the clock when I provide a negative edge to the clock. See the output cycles down back to 3 to 2 to 1 to 0. I'll put that back to the clock. Now for a 2, for T input equals logic 2, the output cycles between either a logic 1 and logic 3 or logic 0 and logic 2, depending on what the state of Q before you set T to logic 2 and apply the clock. So that's a logic 2. That's cycling between a quaternary logic 1 and quaternary logic 3. I just earth it a minute. I lost the flip-flop. Now it's cycling between a quaternary logic 0 and a quaternary logic 2. So that is the operation of the T flip-flop. I can just show you the cycling of the flip-flops between a 0 and a 3, 0 and a 2, sorry, with the negative going edge of the clock. Right. So that is the T-type flip-flop, quaternary T-type flip-flop. Right. Right, so this is the JK flip-flop. I think I've done it right. clock So I'm going to set the output J to a 1 and K to a 3, Quaternary logic 3, and you can see that it counts up. And again, if I cycle the clock from a negative going edge, you can see the output cycles up 0, 1, 2, 3. If I set J to a 3 and K to a 1, you can see that the output, Q output of the JK flip-flop cycles down between 3 to 2 to 1 to 0. Well, this is the same as the T-type flip-flop, except you've got 2 inputs instead of 1. Right, what else can I show you? So two cycles either from a logic J equals 2 and K equals 2, cycles from logic 0 to a logic 2, or a logic 1 to a logic 3. So if I can just, there we go, cycling from a logic 1 to a logic 3 there. It depends on the value of Q when the flip-flop's being clocked. So yeah, that's the value, that's J equals 2 and K equals 2. And the last one I've got to show you is J equals 3 and K equals 3. So yeah, this at the minute is cycling between the values of a logic 1 and a logic 2. It's a square wave, and if I the outputs sort of kind of, and there we go, it's I've earthed it to reset the flip-flop to logic 0, and it's clocked. When it's clocked, it's clocking between a quaternary logic 0 and a quaternary logic 3. So there we go, and I can probably show you that flip-flop on the action of the negative edge. It's cycling between a logic 0 and a logic 3 when the clock goes negative edge, provides a negative edge. Right, I'll put that back. Right, I think that's it. That concludes the presentation. Just like to say, I hope you've enjoyed it. Thanks for watching. Bye.